Do is we're going to start identifying some transformations is what they're called. Remember yesterday when we had a couple of those absolute values that we just had to keep plugging in x's to try and find that v where it had to bounce back up? Today we're going to talk about how we can find that without having to do like all the plugging in forever. So what we're going to do is we're going to find out the transformations. What transformations are is how they move when we're looking at equations. They use A, H, and K. We will quite literally be using A, H, and K with every function we do for the whole year. So we will see A, H, and K a gazillion times this year, and that is barely an exaggeration. Like, we see it that much. Every single chapter uses A, H, and K transformations. Okay, so this is going to be one of those things you want to have this written down. You want to have it clear. We're going to see A, H, and K a bunch. And what it is we're going to look at something called a transformation form, which usually has... Oh, that handwriting is terrible. Hang on, we're going to lock this. So our transformation form is going to be A times something that has our x in it. H gets subtracted from x. And K is added on the end. We'll be able to use this with absolute values. We'll be able to use this with quadratics. We'll be able to use this with exponentials. We'll be able to use this with logarithms. We'll be able to use this with rationals. We'll be able to use this with all the things. A, H, and K will come back a whole bunch of times. And so what I'm going to write down here is what their jobs are. What transformation it tells us about. H, which is always, always, always inside whatever operation it is, whether it's being squared, in an absolute value, whatever. H is always the horizontal shift. That is not a pen. It's a horizontal shift. It moves it left or right. H horizontal, H does the hula. It goes side to side. K does a vertical shift. So that tells you whether it goes up or down. K is like a kite. It just goes up, down. Doesn't do a whole lot of horizontal traveling, just goes up and down. So K is a kite or a kangaroo, where it bounces, however we choose to remember it. A has two different jobs. That's why I did those two first. Those two are pretty simple. Horizontal shift, it moves left and right. Vertical shift, moves up and down. A will tell us whether it's been stretched or compressed. Those are our two words. Compress. And it compresses when A is between 0 and 1. And the way we think about it is A, when it's little numbers, it's just so cute. I want to squish it. It's a compression. I'm going to squish it. It's so little and cute. And when it's a number bigger than 1, A is a big kid and doing its big kid yoga. So it stretches. A is bigger than 1. And we'll see what that looks like here in just a second, but the way I remember it is A is little, it's so cute, I want to squish it. Or if A is a big kid, does its big kid yoga, it's really, really tall and skinny. A has one more job. So stretch and compress is one thought. If A is negative, it reflects, is the math word, over the x-axis. It is important that we are specific that it is the x-axis. We are not going to have any other axis reflections this semester, but it will come up, so we're going to practice being specific. And what it means when it says reflects over the x-axis, it takes whatever our shape is and flips it upside down. So whatever our shape is, it flips it upside down when it reflects over the x-axis. So it just goes floop. And I will show you what these all mean. These are one of those things. We are going to use this enough. You're going to need to know this. A, H, and K are literally in every single chapter. Not even joking, not exaggerating. Every single chapter. Okay, so we're going to not be surprised when the H and K come around again. Okay, we're going to practice with them. Today what we're going to do is we're going to identify A, H, and K. And we're going to use absolute values to do it because we were working with those yesterday. So I'm going to change my view. So we can just look at one at a time. And what we're going to do is we're going to take that transformation form, that A times, it had parentheses on the first page, but it doesn't matter, x minus h plus k. And we are going to find A, H, and K, and we are going to describe the transformations. So we start with just playing match 'em up. We want to identify A, H, and K. A is always multiplied out front. So our A, in this case, is 1/2. H, and we need to be super careful of the sign, is inside, and it will always have the opposite expression, or the opposite sign as the expression inside the box. So this says the absolute value of x plus 1. Our H is -1. Our little formula up here has x minus h to try and help us remember. It always is going to have the opposite sign of that expression.
-1 in the equation, then it would be +1 on h?
Correct. And then we have our k over here, which is just added on the end, which is a +4. Any questions on the identifying of the pieces? Because we're going to come through and describe what this means is going to happen to our picture. So an A of 1/2, 1/2 is between 0 and 1. It's so little and cute, I'm going to squish it. So that is a compression. So this means it will be compressed. So whatever this graph is, it's going to look like somebody sat on it. It's going to be a bit wider than it normally is. An H of -1 means this is going to go left 1 space. That is totally meant to be a T. Yes, dear. Because A is between 0 and 1. It's small. So when A is between 0 and 1, so usually a fraction, not always because the book likes to play games, but if it's between 0 and 1, my picture looks like somebody sat on it. It's going to be squished. So we call that compressed. And our k of positive 4 means it has been moved up 4. Those are all the transformations on here. I'm going to change the way I circled these at the top. Give me just 1 second. So I want you to be able to see still. Purple, green, pink. There we go. That's a little easier to still see the equation than when I circle it. Figured it out. Questions on that first one? We're going to practice this a few more times before we try and use any of these pieces. Okay. We're going to do the same exact thing over here. We are going to find our A. Oh, that's not a pen. Our A, our H, and our K. The A is the number multiplied out front. So what is our A? 3. H is inside and with the opposite sign of our expression. So what is the value of H? 4. And K is added on the end. That's not the highlighter. So our K is what? 1. Those are all the pieces. We're going to say what the heck that means. So here my A is bigger than 1. It is not so little and so cute. It is big, so it is going to wake up early to get to high school and take a great big stretch. Mostly that was because I really needed to stretch my back right there. Because it's bigger than 1. Because 3 is bigger than 1. So it's a big kid. It's getting up early. It's going to do the yoga, like the whole thing. It's going to get really tall. Our H of 4, positive 4, it's going to move to the right 4. Yep. Positive numbers go to the right. So this is going to go right 4. And our K of 1, up 1. So again, this is going to work for all kinds of functions. If it has a structure like this, it is A, H, and K. Okay? We're going to do this a couple more times before we start playing with it in other ways. All right. Zooming it in for us. I'm going to put my transformation form back up here. You probably still have yours visible. Okay. All right, so what is my A on this one over here? Negative 1/4. It's this guy out front. What is my H? What is inside with the X? 0. Good catch. There's nothing being added or subtracted in there. So my H, I don't have one. H is 0. Ooh, that's not a pen. How about K? 2. So for our transformations, A is going to have a couple today, or on this one. Because it's little, it's that fraction, it's between 0 and 1, is little, it's going to be compressed. And because of this negative sign, it's also going to be flipped. It's going to be upside down. The way we put that mathily is it is reflected over the x-axis. That just means it's upside down. We are not going to see reflections over any axis other than x until next semester. But it will come in, so we're going to practice being specific so that when it comes up, we don't have to go, wait, what? So it's a preventative maintenance situation. So the compressed is because it's little, the reflected is because it's negative. Hi. Thank you, sir. Compressed because it's negative, or compressed because it's little, reflected because it's negative. An h of 0, is that going to do anything for us? Nope. He's just going to stay where he is. No horizontal shift. How about a k of 2? Up 2. So then, we're going to do our last one here. Yes, dear. Correct. The negative is just to the reflection. And then we look at the a value like an absolute value as to whether it's smaller than 0. All right, let's do this last one over here. What is our a value? We got 4 times the quantity x plus 2 squared minus 1. What's my a? 4. Boop. 4. What is my h? Not 4. 2. It's inside here, but is it positive 2 or is it negative 2? Negative 2. It doesn't matter if it has that power on the outside, it's still whatever's inside our parentheses. How about our k? Negative 1. Oh, I didn't highlight my negative 1 yet. Boop. There we go. Makes it a little hard to see, but sorry. So an a of 4 tells us what? Stretched. An h of negative 2 tells us what? Left 2. Good. How about k of negative 1? Down 1. Okay. Feeling okay on those? Because we are going to use a, h, and k to save us from those absolute values where we had to do like 12 of them to find the freaking place where it bounced back up. I'm showing you the shortcut so we don't have to do the, oh my gosh, table. Okay, so we are gonna, I believe, graph 2 today. Yes, we're gonna graph 2. And they're kind of simple. We could do this exactly like we did yesterday, where you just pick some and go. And I'm going to show you a kind of graphing that we are going to use like for all the other ones that have A, H, and K. Okay? You only need this graph, like not counting super accurately because we'll just make sure we're correct. Glue sticks are kind of longer. think you're saying that too. More blue sticks in the math office. I'm gonna go find more. See, I've got 2 more spares up here. If anyone doesn't have a functioning blue stick. Okay, so that gives you 2 graphs. Yes, sir. Say it again? It didn't say that. But they'll send you a pass if they mark it, because they have you on the kiosk. Yeah, it usually gets coded different, and I could still mark you absent. So you're fine. Okay. So what we're going to do first is I'm going to find my A, H, and K for this guy. So we're going to think about our transformation form. That, no, this one. A, X minus H plus K. So what do we have here? What transformation's going on? Do we have an A? No. Do we have an H? Yes. What is our H value? 3. Do we have a K? No. So we have an H of 3. What does that tell us? It's going to move right 3. So we have an H of 3. So there's 2 ways to think about this. You can either, for our transformed function, put 3 in the middle, take 2 to the left, 2 to the right. It's a fine way to do it. Or we can take our basicest of basic, the very first one we did yesterday, where we did the absolute value of x. Remember how I said we were going to see that -2, -1, 0, 1, and 2 a gazillion times? I'm taking what is called my parent function here, which is just absolute value of x. Basic, basic. Nothing added, nothing subtracted, nothing crazy. This was the first one we did yesterday. Absolute value of 2, or of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. That's our parent function, right? I can take my basicest of basic. I barely have to think to fill in the table once we get a few practices in it. And we're going to take our x values and we're going to add h. So I'm going to take my -2 plus 3 to give me 1. My -1 plus 3 to give me 2. 0 plus h, 0 plus 3 gives me 3. 1 plus h gives me 4. 2 plus h gives me 5. So if we use our h value when we're going from the parent function, adding h, we put it here, x plus h, okay? We don't have an A, we don't have a K, those play with the Y's. What it is it's Y times A plus K. It's a yak. Or yacked. So that's how we're going to do it. We don't have an A, we don't have a K, so my Y's are going to stay the same. 2, 1, 0, 1, 2. And I'm pulling them from here. So I use my x's of the parent function to find my new x's. I use the y's of my parent function to find my new y's. And we can see we would have needed to add at least 2 or 3 more at the bottom of this table if we did it like we did yesterday with the plug and chug. The AH and K makes it more efficient for us to graph it. It's actually less work, even though we're making 2 tables. And this is X plus H, Y times A plus K, how we're going to graph everything that uses AH and K. It is the same process for everything from now until May. X plus H, Y times A plus K. Same process for everything. It'll be a different parent function for each of our things. But we're going to use this every chapter. Every chapter. Okay? So it's going to come back a zillion times. But this gives us our points that we can plot here. 1, 2. 2, 1. 3, 0. 4, 1. And 5, 2. And we see our shape here. We can see the place where it bounces. We can see that from our first graph yesterday, this has in fact moved right 1, 2, 3 spaces. So you can always flip back to what we did yesterday. That very first one we did was our parent function. This has moved 3 spaces to the right. Our transformations said it was supposed to move 3 spaces to the right, so we did it good. This is a way to double check it without having to find a graphing calculator online.
But that would mean that the other one, the one with the X and Y thing, is wrong, no?
This is not what we're graphing. This is our graph. This is this guy. This is our parent function. Okay, so this is this is the mama. And we use all the transformations to make the right one. So this is just a tool for us to fill this in. This one we're going to write every single time. Okay. We're going to do one more like this, and then we'll do more of them tomorrow. Okay, one more like this. So again, we're going to think about our transformation form. Yours is hopefully on the same screen, so you should be able to see your stuff. X minus H. That's a minus. There we go. Plus K. So what do we have on this one? A, H, or K? Just a K. Just what's added on the end over here. So what is our K value? 2. What is our H value? 0. So a K of 2 means it's going to move how? Up 2. So I'm going to make my parent table. That's what this is called. This is the parent. And it's the absolute value of X. Basic. Nothing added on, nothing changed. No A, no H, no K. The parent table uses our -2, -1, 0, 1, and 2. Our Y's are 2, 1, 0, 1, and 2. We've done the absolute value of the left column. It's the exact same parent table as the left one had, or as the last one had. To make our transformed function, we make another table, and that gives us X plus H is what we put there. And we're going to do Y times A, when we have one, plus K. So we already said we don't have an h, so we're going to just take these x's and bring them over. We don't really have an x, so we're just going to plop these guys over. Or we don't really have an h. So -2, -1, 0, 1, and 2. And then we do have a k, so we're going to take our y's. I'll change this color to be slightly different. Add it to k and bring it over. So 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. Yes. Yep. I'm taking this column plus my k and putting it in this column. So the x's, we would add to h, but we don't have an h, so we just plop them in. Okay? That gives us our points to graph. Yeah. So it's always going to be from this parent function. So this is going to be the same for any absolute value. It's always going to be -2 to 2. I mean, you can technically use anything you want, but having it in the same each time makes it easier to do. Okay, so plot our points. -2, 4. -1, 3. 0, 2. 1, 3. And 2, 4. And we see... Oh, that was a bad one. There we go. You're going to use a ruler because these are absolute values, which are V-shaped. Like this. As we get more A's, H's, and K's worked in, things are going to change more. We just kind of wanted to practice it easy peasy before we had some like challenging graph ones that we're going to work with tomorrow. We're going to work more with A, H, and K tomorrow. And like I said, A, H, and K are going to come up over the next year a bunch of times, which is why we're going to practice identifying A, H, and K. Yeah, woohoo. Okay, so the front side is identify transformations. The back side, you can try on the graphs. Like the ones we did, but they are a little harder, so they're more like the ones we're going to do tomorrow. They have A, H, and K. So smush them all together. It's still X plus H and yak. Y times A plus K. Okay? So you can try if you want to. I always have extra copies. You're always welcome to try. Okay? Yes, you. None. I'd rather do it right than you do fast. Okay? All right, so this is homework 7, and this is, I am 95% sure, the last homework of the chapter. I'm not willing to commit 100 without looking at it, but I'm going to go with 95. This is the last one. Okay? So, question number 1, A through G, is identifying A, H, and K. Tell me what they are and what change is happening. So you guys have the next 10 minutes. Let's see, boop. Yeah, to work on homework 7. You doing this thing, just like we had here. Okay, so that's what question 1 is. What is A? What's it mean? What is H? What does it mean? What is K? What does it mean? Okay, so use this time, work on homework 7, ask questions. I'm here to help. I'd love to help. And all that jazz. Let me turn off the screen.